Hello viewers, welcome to my channel, and in this video we are going to discuss third internal test solution of data science subject. So our first question is discuss attribute by attribute problem that may found into the following data set. So we have provided a data set which have the uh, column as customer ID, zip, gender, income, marital status, and its amount. So you can see that we have very irregularity in the entries. So we will see the problem attribute by attribute. Let's start with customer ID. So variable seems to be fine. Now in the attribute of zip, here we are expecting all the customers in the data set to have usual 5 numerical US zip code. The customer 1002 is okay. Now the customer 1002 has zip code T2LZK7. Unusual value may be an error and toss it out. But not all country uses the same zip code format. Actually, this is the zip code of Saint Hyacinthe, Quebec, Canada. So probably represent real data from our real customer. So now the customer 1003 is okay. And for customer 1004, we are unaware of any country that have 4-digit zip code such as 6269. But it can be an error as well. Uh, can it? Probably not, because some cities in British country uses zero as their first number. Maybe it might have been what we call it deprecated or deleted, trimmed because of zero present in the starting. Now for zip code, so for the New England state, begin with the numbered zero, as I told you earlier. Unless the zip code field is defined to be character, text, and not numeric, the software will probably chop off the leading zero, which is apparently that happened here. Now the zip code is probably 06269, which is referred to stores Connecticut. Now gender attribute contain a missing value for customer 1003. Now in the income field, uh, the income field is measuring annual gross income and has three potential anomalies values. So in the customer 1003, income is 10 lakh, you can say, or 10 million, sorry, per year. So possible, especially when considering the customer zip code, which is 90210, Beverly Hills. So this value of income is nevertheless an outlier stream data value. Certain statistical and data mining modeling techniques do not function smoothly in the presence of outlier. Poverty is one thing, but it is rare to find an income that is negative, as our poor customer 1004 has. So the customer 1004 reported income of minus $40,000, lies beyond the fail bound for income and therefore must be an error. So it is unclear how this error crept in, with perhaps the most likely explanation being that the negative sign is a stray data entry. However, we cannot be sure and approach this value cautiously. Attempting to communicate with the database manager, most familiar with the database history, is can be done. Now for customer 1005, income of $99,999. Perhaps it may be in fact be valid, but if all the other values are rounded to the nearest $5,000 or maybe by the precision with customer 1005, often in legacy databases, certainly specified values are meant to be code for anomalous entries such as missing values. Perhaps 99,999 was coded in an old database to meaning missing. Now, finally, are we clear as to which unit of measures the income value are? Databases often get merged, sometimes without bothering to check whether such mergers are entirely appropriate for all fields or not. Like for example, it's quite possible that a customer 1002 with the Canadian zip code has income messages in Canadian dollar, not US dollar. So it might create an imbalance in their, so the data set would not be that accurate. Now in the age field have also a couple of problems, like for the customer age of customer 1001 is C, probably reflects on earlier categorization of this age in a bin labeled C. The data mining software will definitely not like this category value in an otherwise numerical field and will have to resolve problem somehow. Customer 1004 age is 0. Perhaps there is a newborn male living in Storm, Connecticut who has made a transaction of 1000 and it is impossible, more likely. The age of this person is probably missing and was coded as 0 to indicate that there is an anomalous condition. Of course, keeping an age field in a database is a minefield in itself, since the passage of time will quickly make the value field obsolete and misleading. So it's better to keep data type fields such as date of birth or birth date in our data set and through which we can calculate their age. It will be more hand in hand. Now, marital status field seems right, but maybe not. Let's check it out. The problem lies in the meaning behind these symbols. I think we know that we know what these symbols mean, but are sometimes surprised. Like in this case here, you can see that in the above table, uh, as there are rows which have S for customer 1003 and for 1004. So whether this S denotes single or separated, so it is also confusion. It can create a confusion. And now in the transactions, so transaction amount field seems satisfactory as long as we are confident that we know what unit of NISA is being used and that all records are transactions in this unit. Now we will have to, in the second question, we will have to apply data type process in the following data set. So we have given a data set here name. You can see that every name is in different order. Like first, some name have their surname before their original name. Some are using comma, while that's how it is mentioned in phone number. You can see that there is a different formats of phone number. Same with birthday. Also states some using their abbreviation. So all names are now formatted the same way, first name and last name. Now phone numbers are also formatted the same way. Area code, that's ABC, that's their number. Now data formatted numerically, which is in the form of YYYY. That means year will come before month and then month will come before date. Now states are not abbreviated. And the entry for Zaki Agrawal did not have fully formed data. Some area code on the phone number is missing and the birth date had no year. So it was discarded from the dataset. Now that the resulting dataset is cleaned, readable for employment or evaluation. Now after this, you will get this resultant data as this. Your name have been formatted in the same way. Phone number have also been formatted in the same way. Same thing we have done with the birth date. So where we have first year, then the month name and then date. And in the state we have expanded all these abbreviations that were written before. Now, in the third question, we have to classify bank loan application by assigning application to one of the three risk class, which are A, B, C respectively, and we will have to use entropy and information gain approach. So here we have three fields or four columns. Sorry, five columns on the basis of which we will have to find um, assign a risk class. So the columns are own home, married, gender, employed, credit ranking, etc. So first we will find the entropy of the whole data set, which is 1.57. The calculation. Own home has two values, which is yes or no, whether he owns home or not. So for an entropy of Yes is 1.5. The entropy of N is also 1.52. The information gain of our own home will be 0.05. You can see that I have also mentioned the formula here, so you can reference these formulas to calculate the values. And in the further calculation, I have not mentioned these formulas. So uh, I have directly written their computed result. Now, so we have got the information gain of own home. Now for married, we have two values, yes and no, which are 0.772 and 0.97. So information gain merit is 0.724. Now similarly for information gain of gender, we can calculate uh, 0.879. And now in employees, whether he's an employee, yes or no. So we will find their respective entropy, and then we will, with the help of them, will find the entropy of merit. I have here done here a little mistake. It is not merit, it is employed. Information gain of employed will be 0.446. Now, similarly, we can find the information gain of credit ranking. I have all directly written the information gain, which is 0.05. Now, when you will observe all these information gain values, you will get to know, or you will conclude that the gender has maximum information gain as it is taken as a root node. So now we have taken gender as root node. So all the genders which are male are come under B risk class. If you will observe that. Now we will have a table, or we will make a subtable of that table which have only females as their entry. Now we will find the entropy of the whole data set with respect to this table, and it will be 0.985. Now whether he own home or not, value will be yes or no. Now we will calculate the information gain of own home, which will be 0.15. And now married also has two values, yes and no. So we will find their respective entropy, which are 0, 0, and then we will calculate the total entropy gain, which is 0.985. Since the entropy of the whole data set is 0.985, and you can see that the information gain is maximum, which is 0.985. Thus, Marriott has maximum information gain, thus it is taken as a splitting node. So after the calculation, after finding the root or splitting node, the fixing interrupt and information gain approach will seem like this. So if a gender is male, then he will be assigned a P in this class. And if it's a female, then we will further say whether she is married or not. If she is married, then she comes under C class, and if she is not married, then she comes under A risk class. Now we have to solve this process again through by using gain index approach here, and we will see here that first we will now going to find the gain index for own home. So own home has two values, yes and no. So we will find the gain index for respective yes and no value, which are 0.64 and 0.64. So then now the gain index of own home attribute will be 0.64 as well. Now for married, there are two values which are whether he is married or he or she is married or not. So we will find their gain index for yes and no, and then the resultant gain index value for married will be 0.40. And for gender, whether uh, the person can be male or female, so we will find their respective gain index, which is 0 and 0.511, and then the gain index of gender will be 0.358. Now, whether he is employed or not, so we will find their respective gain index for yes and no respectively, and then we will find the employed information, sorry, gain index of employed, which is as 0.47. So similarly, we will find the Gini index of credit ranking, which is 0.64. Since the gender has minimum Gini index, thus it is taken as root node. Now, as we have done before, then we will again create a subtable of that table, which will only have female as their entry in gender. So now we are going to calculate the Gini index of each attribute respective to this table. So yeah, now what we have done is that first we are going to uh, check whether on home value. So it has two value, yes and no. So the value for yes is 0.44 and the gain index value for no is 0.5. So the gain index value for own home will be 0.474. And for merit, there are two values which is yes and no. So we will find the gain index for yes and no respectively, which are 0, 0, and thus the gain index for 0, 0 mhm, or gain index for merit will be 0. Since the Gini index of merit attribute is 0, that is, it is a pure attribute, thus it is taken as a splitting node. Now the decision tree with respect to Gini index approach will similar to the decision tree of entropy and information gain approach. Like if the customer or the person is gender, then sorry, if the gender of the person is male, then he will come under B class, this class, and if the person is female and she is married, then she will come under the risk class, and if she is not married, then she will come under E subclass, risk class. So thank you for watching this video. See you next time. Thank you.